Uh, Good afternoon, everybody. My name is Alec McAllister. I'm the Associate Director for Advocacy and Engagement with Engineers Ireland. I'd like to welcome you to this afternoon's webinar by the Electrical Division Working Group. We have a particularly interesting subject today, a paper being presented by Padraig Plunkett. Many of you will know Padraig already. He's a chartered engineer with over 35 years of international experience in HV power systems, including 10 years in manufacture of power transformer poles, 10 years as a HV owner's engineer with Mott MacDonald, and 15 years managing HV design and build contractors. So I think it's safe to say we're in the hands of an expert today. And Padraig will be presenting a paper on the competence of persons controlling, operating, and working on HV apparatus. We'll have a question and answer session afterwards. So I'll hand you over to our presenter, Padraig. If you'd like to take the stage, please.
Thanks, Alex. I better not miss the 14-yard free now after that glowing introduction. Anyway, welcome everybody. This is I have a brief presentation, about 30 minutes on the issues paper, and then we'll have plenty of time for questions. If you can put the questions in the Q&A box, Chris McLaughlin, who's here representing IET, will manage that space, and we'll deal with them at the end. Also, this is being recorded, by the way, and a recording and the notes will be made available to everybody later in the week or sometime next week. Okay. Let me see now. Okay, so the paper is mainly focused on competence, but we also went into some associated areas and the factors which would be fundamental to deeming a person competent. So if you haven't actually read the paper yet or know where it is, there's a link there where it can be found on the Engineers Ireland website. The presentation will follow generally the paper in terms of the sections and format. I've moved things around a little bit. So for instance, the methodology, which would be in section 6 of the paper, we'll deal with it next, and or deal with it as number 2, and then you can see the other sections there where I've noted them beside their presentation number. The issues identified, I suppose, in the paper have existed for quite a while, and there have been accidents in Ireland and outside Ireland, and involving companies, who work in Ireland and people resident in Ireland and so forth. But I suppose it always has been at a low level, but in a rapidly expanding industry, this had the potential, or has the potential, to become a more serious problem. So that was really the starting point for this bit of work. So we identified that the electricity infrastructure was significantly expanding, to cater with the high demand growth and also with the network transformation needed to meet the government targets in the climate action plan and so on. All of that then will lead to an increase in the number and the diversity of organizations and people working in the industry. And so put those two together and you have a bigger potential deficit in knowledge and guidance regarding the process to be followed and how to deem somebody competent to manage and operate a HV plant. So we got the working group together in 2019. Appendix 1 in the paper has some bios on everybody. I'd like to take this opportunity to thank all the working group members for their contribution and acknowledge their great expertise and experience. I'd also like to thank Engineers Ireland for facilitating the work and IET for co-hosting it, this webinar, And I'd also finally like to thank ESB Networks and Senelec and the survey respondents and all the others who actually helped provide information and made contributions to this body of work. So if we look at the methodology we used, how we went about doing this work, the first thing we agreed on was that that competence can only be determined and confirmed within a controlled environment and one that's supported by legislation and regulations and standards. So we first set about finding out what that environment actually was in Ireland. So we considered, first of all, our collective knowledge and experience. We reviewed the applicable legislation, regulations, and standards. We also sought advice from Senelec. A number of us are on the Senelec committees, so we sought their advice in relation to best practice in other Senelec countries. And then we actually surveyed the wider electrical division and energy sector using a survey which we sent directly to people, and then also a questionnaire which was sent out to about 2,500 members. Both survey and questionnaire focused on 4 particular areas: the compliance with the applicable standard, which is EN 5110, the competence requirements for the nominated persons and roles specified in that standard, and the assessment of competence for persons and companies. In other words, how people are currently going about that, and then the opinions of stakeholders, what people felt should be done, was not being done, etc. So the survey was completed and returned, or the questionnaire, I should say, I think the survey was completed and returned by 134 Engineers Ireland members and 9 non-members. And then the questionnaire was probably sent to about, I'd say, 50 or 100 different people, and we got some really good responses back and really good contributions from people, including ESB Networks. So to take a look at the environment which is presented in section 3 of the paper, titled Background, if we look at the legislation, regulations and standards piece, that's a standard pyramid there with the Act on top. Regulations are mandatory, and then you get down to codes of practice and guidance material. And the approved code of practice here is important insofar as it is effectively a mandatory standard, and our recommendations will involve status for 2 standards. So we'll be looking at that later. In terms of the legislation, we have the Show Act 2005, which puts certain duties on employers and owners. And then we also have the Show General Applications Regulations, Part 3 Electricity from 2007. And there's a useful guide to that published on the HSA website, which is this one here with the yellow cover. In that, in the Show regulations, there are 2 particular regulations that are very relevant to competence and very relevant to this area. One is the suitability of equipment and installations, number 76, and the number 88 then is persons to be competent to prevent danger, and I'll go into detail a little bit on those as we go along. So in terms of 76, it says that employer shall ensure that all electrical equipment and installations are designed, constructed, installed, maintained, protected and used so as to prevent danger. We have a couple of standards which help us to comply with this regulation. One of them being IEC 61936. It's also an ISEN 61936, and then there's a standard recommendation 61936. And we didn't deal with this particular area in detail in the report, but it's just worth noting it. SR 61936 replaced ET 103, which was published in 2015, which was a body of work that the ETCI did over 10 years, which had the requirements of the IEC 61936 plus a lot of national requirements for Ireland. So that all went into that document and then into SR 61936. But we've been successful in translating a lot of that information, the national information, into the new version of the IEC 61936, which came out in 2021. And that then, following an extensive bureaucratic process at Senelec, will eventually come out as EN 61936, probably late this year, and then will be transferred or converted to an ISEN 61936. So at the moment, the current, or the most up-to-date standard to follow is the IEC 61936 from 2021. So that's, as I say, that's part of creating the environment for deeming somebody competent. We went into a lot more detail, I suppose, in regard to EN 5110. And this is a key standard and a means of compliance with 76.6, in other words, that you would use electrical equipment so as to prevent danger. This standard is in place since 1996, so it's about 25 years. The current issue is March 2013, but there is a revision due on that as well, and that will be out again, hopefully later this year. The other thing to note here is that IEC have started a project committee 128 in this area, and the intention is to issue an IEC standard probably 2 or 3 years time. And Nick Hogan and myself are members of this PC 128 also, and also the associated NSAI and Senelec committees. So then if we look at how all this transfers into duties to installation owners, again, we have the Shaw GAR 76, duty number 1 in regard to the operation and the management of the installation. It must be used to prevent danger. And then Regulation 88, which basically says that no person engaged in work or the persons must be competent or under a degree of supervision as is appropriate by a competent person. And then a quick look at best practice in Europe in relation to how to carry out those duties and comply with the regulations. 5110 is generally accepted in Europe as a minimum standard. This was actually confirmed to us by 6 countries, Denmark, Finland, France, Germany, Norway, and Sweden. And we have an appendix 4 in the issues paper, which goes into a little bit of detail on how they do that. It's generally, as I said, a minimum standard. In some, Sweden, for instance, have gone even further to say that really, if an accident happens, that even if you complied with the minimum standard, you know, there's still a liability there. So on the other hand, we're in Ireland, we don't have a minimum standard specified, so we're a little bit off the pace in terms of best practice. So looking at the roles and responsibilities in 5110, which is what you would be deeming somebody competent to do. The first role is the installation manager, the 321, the person responsible for an electrical installation, and that person is a nominated person with overall responsibility for the safe operation of the installation. And he does that by setting rules and organization or framework for the installation. And that covers LV to HV. There's no boundary or split between LV works and HV works in 5110. The second role then is the nominated person in control of an electrical installation during work activities, and that's the new name for that person in the new version of the standard is the operation controller, and people would probably be familiar with the term control engineer or even SAP. That would be the role there where the person controls the installation and responsible for the installation, but under the rules set by the installation manager. And then the third role is the work controller. I suppose people would be responsible or would be familiar with PICW or supervisor, that type of role. Could be an authorized person. And then a skilled person, electrically, again, a competent person, could be the person carrying out the test or doing the maintenance or whatever that the work was. And just graphically then to see those roles, you see the person, the installation manager has the complete installation under their control, whereas the operation controller could be given a small part of it, and you could have 2 or more operation controllers in control of an installation during work. And then if that was the case, you would have a cross-boundary procedure here between the 2 of them. And then where the work is carrying on, you'll have the person in control of the work activity and the skilled people there, the competent people working as the working team. So just to look at then particular duties, regulations and standards, etc., in regard to competence, and this is dealt with in section 3.4 of the paper, just to present what we have. Again, we have Regulation 88, that persons must be competent or under the supervision of a competent person. We have a standard, ISEN 5110, which in section 4.2 gives some guidance on what would make up competence, or what should be used in assessing the competence. And it's five areas there: knowledge of electricity, experience of electrical work, understanding the installation to be worked on and practical experience of that work, understanding the hazards which can arise and precautions to be observed, and the ability to recognize at all times that it's safe to continue working. The HSA guidance document on Regulation 88 also presents similar guidance, and it's very, very similar to 5110, except in terms of the understanding and experience, where the HSA document specifies an adequate understanding of the installation type to be worked on and practical experience of the class of installation, whereas 5110 specifies understanding of the installation and that particular work. So in a HV situation, a complex HV installation, really the 5110 is the most onerous requirement. But I suppose if you consider the last one here, the ability to recognize at all times when it's safe to continue working, you could argue that both approaches end up in the same place, because unless you are familiar with the particular organization, you probably aren't in a position to recognize when it's safe or not safe to continue working. But in any case, if we look at the Shaw Act and the duties on employers and owners, and Part 7 offences and penalties, basically under this legislation, you're presumed guilty until you prove yourself innocent, and it shall be for the accused to prove, as the case may be, that it was not practical or not reasonably practical to do more than was in fact done to satisfy the duty or requirement. So bottom line there is that where reasonably practical, 5110 should apply in our view. And for example, that would mean that all persons working on or near HV installations should be given familiarization training on that particular installation. So for instance, the practice of hiring an SAP and sending them in to take control of an installation without giving that person some familiarization training would not necessarily comply, in our view, with 5110, and again, in our view, would probably not satisfy this duty to do everything that was reasonably practical. But I mean, that's for probably other people to decide. So that was really the environment, and then we went looked at all the information that came back and, you know, identified a lot of different issues, but we summarized them, or we condensed them down into 3 issues. The first one being the non-compliance with Shaw General Application Regulation 76.6, that the employer shall ensure that the installation is used to prevent danger. We found a general deficit in the awareness, general lack of awareness about 5110, and we concluded that a lot of installations, you know, were not being managed in accordance with 5110, and so were probably not in accordance with Shaw 76. So again, the logical conclusion there is that the necessary environment is not being provided always for people to be assessed and authorized as being competent to work on HV installations. And so those particular owners or employers may not be considered to be taking all reasonably practical measures to prevent danger. So that was the first one. The next one then is related to that, but it's specifically in relation to Shaw Regulation 88. We found that the roles and the associated competence for those roles, again, was not well understood. So in this situation, then there is obviously a significant risk that persons nominated to go in and manage or operate HV or control HV installations wouldn't have the adequate training or skills to satisfy the competence requirements in 5110, and then by extension Shaw 88. And again, in these cases, the employers may not have taken the reasonably practical measures to prevent danger. And the third one is, it's not a surprise, I'd imagine, to most people. We don't have a regulatory scheme for HV works. We have one for LV, but we don't have one for HV. And so we wouldn't be following best practice, European best practice in this regard, because most Senelec countries would have some form of scheme for works and HV works, and for people working in HV, in the HV environment. So then, to look at the fixes, the recommendations, thankfully you know, there's a simple enough fix to the first 2 issues. What we would recommend, what we are recommending, is that both standards 61936 and 5110 are given a mandatory status, that in other words, that they would have the same status as the HSA approved codes of practice. In other words, that they would be a minimum standard to be respected for HV installations, works and operations. And similarly then with the competence piece, that 5110 would be seen as the minimum requirement for competence for work on or near HV installations. Now we have the justification for all of this is simply that we would follow European best practice. But I do have an example later on of how this approach could have prevented an accident. And again, it's just an example that we'll use. And the final recommendation is that we actually introduce a regulatory scheme for HV. So it could be a safe electric type scheme, but to include HV, or a separate one for HV, or whatever. Now, on the face of it, I suppose that's a very, very big task, but and it is a big task. But I mean, the good news, I suppose, is that I think if we get the first 2 right, if we make the standards mandatory, the industry will, to a certain extent, to a large extent, self-regulate, because thankfully the industry is actually made up of very responsible people. So we would be hopeful that if we get the first 2 right, that it mightn't be such a big thing to bring in an actual formal scheme to regulate the HV industry. Okay, that's the issues and recommendations. If we move on then to just a little bit of what else is in the paper, there's section 7.1 deals with the survey findings, and there's a lot of information in there, a lot of graphs, a lot of statistics. It took a long time to produce them. It's probably, and understand them. They mightn't be so easy to understand for the reader. Hopefully they are, but this is just one example here where in terms of the answer to, is there a formally nominated person responsible for the HV installation, the HV system manager, installation manager is the new name, and 39% said yes, I think 23% said no, and 38% or something like that skipped the question, so assume that's also no. So we can probably deduce there that only 39% of people got over the first fence in terms of compliance with 5110. So that's the background to where our issues came from. On the general findings, which would be mainly the questionnaire and maybe comments back from the survey, we did find that there was a general preference. A lot of people expressed a preference to have competence of persons regulated by a national body. We found that there was probably a presumption that HV contractors would have competent people. There's probably an over-reliance on HV contractors to fix the problem, to come in with competent people and rules and control the situation. We think that's unreasonable probably, and probably unfair to HV contractors to put that amount of responsibility on them. The standard is very clear in terms of specifying that the installation must have an installation manager, and the installation must have the rules. And if you think about it, the way utilities operate, utilities have rules for their complete network, and they don't allow anybody to come in and operate their network unless they're operating under their rules. ESB Networks did engage very well with us and provided a lot of really good information and supported us very well and support this paper. And they have done a lot of work recently in terms of developing the process for assessing competence and authorizing persons. And that's contained in 7.2, and it basically involves 4 areas. The first area is to identify the safety critical activities that will be carried out. The next one is the qualification process, which would be around education and training to provide the basic knowledge. And then the authorization process to actually approve the person as being competent, who has basic qualifications, but proving them as competent to carry out a specific task. And that might involve additional training on that specific role or task. And then finally, a review process whereby people who are deemed to be competent are continually reassessed over maybe every 2 or 3 years, and their authorizations are renewed or withdrawn based on their activity and their which should be recorded in something maybe like a logbook, so that it can be seen that even though a person who was deemed competent 3 years ago has been working in that area continuously for that 3 years, and so can renew their authorization. So in conclusion, Engineers Ireland and IET, while we have have this paper as an initiative. It's both organizations can only offer advice and provide information. So they're the voice of the electrical and engineering profession. Both organizations can engage, with the relevant stakeholders who have the duties and responsibilities. But I stress again that it's their role is to provide information and identify issues and suggest recommendations. And finally, both institutions can inform their members in regard to best practice. And in that regard, Engineers Ireland offer this training course twice a year or thereabouts. And the course does cover pretty much all the areas necessary to confirm compliance with SHAW 76, SHAW GAR 76, whereby the employer must ensure that the installation is designed, constructed, installed, maintained, protected, and used to prevent danger. The maintained bit is not included really in either 61936 or 50110, but we do in the course give some information as to how somebody could maintain an installation to prevent danger. And finally, then just this is dealt with. It's an extract from the course. Again, the incident that I referred to. This is just an example of how 50110 could prevent an accident. This is an accident happened in Scotland in 2020. I would absolutely stress that all the parties involved here are reputable organizations. They take electrical safety very, very seriously. I know that from working with them and knowing them. They carried out a thorough investigation into this, and there was a webinar given on the subject, which I attended. But it came out through the webinar that a local alert wasn't actually applied. The incident involved somebody working on a pre-insertion resistor, two pre-insertion resistors close together. He was working on one, and there was a misidentification, and the wrong circuit was energized. Unfortunately, his circuit was energized, and he sustained serious injuries. But unfortunately, I suppose 50110 isn't a mandatory standard in the UK either. So it wouldn't necessarily have been, included in the investigation, but it did come out in the webinar that local alert wasn't applied to the pre-insertion resistor to the conductors that the person was working on, and that is a requirement in 50110. And if it had been done, obviously the local alert would have diverted the fault current and tripped the circuit, and we would have ended up with a near miss rather than an accident. So it's just there as an example of how 50110 could help. Another little extract from the just to give a background from the course. We all know the 5 rules, but it's the sequence is important in how they're applied. In terms of verifying the absence of voltage, the Swedish Safety Board have determined that accurate or proper detection of voltage or detection for voltage could prevent the majority of accidents. And associated with that, then obviously is the earthing, and we see there for bare conductors, earthing and short circuit shall be carried out on all sides of the work location and on all conductors entering this location. And at least one of the earthing and short circuiting equipment or devices shall be visible. So while in the case of that incident, the circuit was earthed back at the switchboard, there was no local alert visible. So and no local alert to protect the individual. So that was the unfortunately the root cause. So that's really the end of the presentation. thank you for your attention. If there's questions, I'll hand back over to Chris.
That being the case, I'd like to thank Padraig for an excellent presentation and for his most comprehensive coverage of the issues involved. On behalf of the IET Ireland Network, I wish to say that we were delighted to accept Engineers Ireland Electrical Division's invitation to co-host the webinar. Thanks also go to Engineers Ireland for facilitating the setting up of the working group within the Electrical Division to examine the issues around HV and competence of persons, and for the work of the group members in completing the issues paper. The group members include Mick O'Grady, Gerard Buckley, Mick Hogan, Michael Smethwick and myself representing the Ireland Network, under the stewardship of Orla Burke and the first-rate guidance and direction of Padraig Plunkett. Thanks also go to Sinead Quinn Phillips, who provided excellent support, including organising the survey of interested parties, the results of which formed a vital part of the paper. Now that the issues around HV and competence of persons have been identified, we look forward to the relevant bodies taking them on board with a view to their resolution. A final thanks again to the Electrical Division, Orla, Padraig, Alec for today's webinar, and to Padraig for his excellent presentation. Under present conditions, it's not possible to offer Padraig the traditional round of applause, so many congratulations again for your presentation.